Yeah, well, I guess it's now the second item in the agenda. I was going to see what we have this little tool we wanted to demo, and the engineers that built it from Google live in Australia. So I was going to see if I could find one of the future meetings that was an Australia-friendly time zone. So I think we have something scheduled for the 11th, so I was going to propose the 25th to move this time to be an early afternoon time, so 2 p.m. or 3 p.m. So look out for that. I will move the meeting time. And then I think going forward, if there's a lot of interest in like flipping the time zones, we should talk about that, and maybe we can alternate. I think that's what a lot of groups do for something that's more APAC friendly. So that is it from me. And I think today we have a demo of Tracy. Am I pronouncing it right?
Yes. Hi.
Hello.
Yeah. So hello everyone. My name is Itai. I'm from Aqua Security, from the open source team in Aqua Security. I think we should also have Idan from Aqua as well. Although I don't see him. Oh yeah, he's now joined.
I'm here. Hi everyone.
So yeah, Idan is Superman. He's from the research team in Aqua Security, so they do quite incredible stuff. I watched a few. This is the first time that I'm joining the meeting. I watched a few recordings on YouTube before, and I saw that you were working on the package feeds and scanning of like trying to detect malicious packages in package repositories, and it rang the bell because we were working on similar stuff. So I said, why not jumping, show you what we were working on, and maybe we could collaborate on something. So I think I'm going to start by just first of all introducing you to Tracy, which is the tool that we use to drive a lot of this work, and then maybe we can talk besides the technology about our goals and so on. So I didn't prepare a presentation or anything. I can do a quick demo. First, I just want to say that Tracy is a runtime security and forensics tools using eBPF. This is not the usual audience that I give this demo to, so I assume that you kind of know what runtime security means, eBPF means. It's basically what we do is we trace the operating system, Linux operating system, using the eBPF technology, and we collect a lot of events. We analyze them to detect suspicious behavioral patterns. Tracy, by the way, is open source. It is Apache 2 license, so people can and are encouraged to use Tracy to do other stuff besides what I'm about to demonstrate to you. So Tracy basically is composed of two parts. The first one is Tracy eBPF, which is just a system tracing tool. It's a CLI tool that you would run it. You can configure it to specify exactly what you want to trace, and it will start collecting events from the operating system. Events can be stuff like system calls. Events can be stuff like internal kernel functions even that we trace. It can be a lot of things, and it's also an extensible platform. But usually what most people are interested in is tracing system call. Once you start Tracy eBPF, the CLI tool, it will start collecting events from the operating system, and like that tool by itself is quite useful for people who want to understand what's going on, to do some security research maybe, or to debug or troubleshoot applications or stuff like that. It has a very comprehensive set of filters that can allow you to very precisely specify what you want it to trace. Actually, I can share my screen for a second. Just a second. Can't share screen. All right, I need to give it permissions. This is the first time that I'm using Google Meet, so apologies.
But I just slipped in some URLs so that people can go learn more
Thank
later.
you. Thank you.
And they are already in the notes. Kim?
Sorry, what was that?
I was making sure you knew that the URLs I mentioned are they're already in those notes.
Oh, yeah. Nice.
All right, I'm gonna have to quit and reopen for it to get the permissions. I'm sorry, so I'm jumping right back in.
Sorry. I think we all understand the demo gods. Sometimes sacrifices just are not enough.
Anyone have any other topics while we wait?
Well, it's not a new topic, but I was going to ask him about. Welcome back. Sometime when you get a chance, I'd love to chat about how in the world to use Tracy to discover things that sit around for a while. Unfortunately, increasingly, a lot of these malicious tools will play nice for a while. SolarWinds, for example, it was random, but I think it was average was like 2 weeks before it started to do its thing. Which makes it obviously harder to detect. And you can play games with clocks. I don't know if you've got any experience with trying to detect malicious code that's trying to be stealthier, and any tips.
Yeah, I think I'm going to let Idan take that after we. No, it's a good question that I think it's being asked. So let's get the demo first out of the way,
Okay.
and then we can talk about.
And I appreciate that's hard, and nothing is guaranteed. So.
Yeah.
But what we can do to try to make it a little harder for the adversaries seems like a great thing, even though what I'm asking is, I understand, very, very challenging.
Yeah. All right, so now I should be sharing.
Yes. I
Do you
see it.
see something? Okay,
Yes,
cool.
we do. Spectacular. Thank you.
So
I'm going to request for you to increase your font size. It'll help
course,
at least.
Of course.
Thank you. Appreciate it.
Get this out of the way. All right, so you can start Tracy and tell it to trace a very comprehensive filtering mechanism. You can tell it like, I want this system call, I want this set of system calls, I want this process ID, this process ID tree, I want to trace new containers, I want to trace a particular container. You can look at data that comes out of the traced system call and say, okay, actually there's when I'm tracing this system call, it's going to return an argument. So I want to see if that argument is going to be equal to something. Only that is interesting to me. So I'm not going to go into that. Just want to say that there's a very comprehensive filtering mechanism that allows you to precisely express what set of events you want to extract. And I also want to mention that besides system calls, we also trace other events. For example, we plug into internal kernel functions that allows us to get more reliable information. For example, a very common thing that people want to trace is execve system call, which is the system call used to execute anything. But that's actually somewhat, it can be manipulated in some way. So we have an alternative, for example, to trace the security BPRM check, which is an internal kernel function that is guaranteed to provide a more accurate and reliable information that is that's more useful in a security setting. So it's just one example. We have a number of those. A number of those cases where we allow you to trace not only system calls, but other events that happen in the operating system. And the reason why this is important is because we're discussing security here. If this was, just another monitoring tool, it probably was meaningless. But because we are looking for very specific things, and we know that the other party is trying to hide from us all the time, it can be helpful to trace these as well. I'm fast forwarding through that because I want to get to the more interesting part. We can maybe dive into other areas at the end. So I mentioned that there is Tracy eBPF, which is the CLI tool, and there's also Tracy rules, which is the rule engine. Basically, you can run them individually. You can run Tracy eBPF, get the stream of events, and feed it to whatever processing tool you want. But we also have the processing tool, which is the rule engine. The rule engine lets you create what we call behavioral signatures that looks for specific patterns in the stream of events that you get. We're supporting two ways to author signatures. One is using Golang. This is an example for a signature. Don't want to get into that business logic now. I just want to show that it can be quite comprehensive and complex code that is looking for actually more than just into an event. It can do things like keep state and track a complex behavior a long time to see that something is happening. In this example, this signature, yeah.
Yeah. Okay. So there are actually two parts. One records events, and one's the rule engine. Can you tell me what exactly you name each, so that I know when you're talking about which?
Yeah. So one is called. Let me just open this as a reference. One is called Tracy eBPF, which is collecting the events.
eBPF.
eBPF. eBPF
Okay.
is the technology that we use in order to instrument the operating system. And the other one is called Tracy rules, which is the rule engine. Okay.
Okay. All right. E.g., potentially malicious behavior. Okay. Those of you who are looking at the notes, you can see what nonsense I'm writing down and hopefully capture it. Now, because it depends on eBPF, that obviously requires that the underlying kernel have eBPF, which is true for Linux. But obviously that you're depending on that particular technology. Thanks.
Yes, it is a Linux, security tool, and not only does it requires eBPF, we actually use some specific features. So we need kernel 4.18 and above. We think it's pretty reasonable. I mean, most people probably already are using that.
Yeah. Version what number?
4.18.
4.18. Oh yeah.
Everything is on the README and GitHub. So if people want to really experiment with it, you have the information there. So I started to say that signatures, which are the way that you can express what you are looking for exactly, can be written in Golang. And if you write a signature in Golang, it's just a Go program that you can write. We orchestrate like feeding it the relevant events and you just handle the events and see if you're interested in something there. And it can be, any arbitrary code. You can also track state, which is a very, I think, a powerful feature. This particular signature, for example, looks for if someone is opening a socket and then redirecting standard output over that socket. So it's trying to, exfiltrate whatever is going on. And for that to happen, we need to track actually a number of system calls, but not only those system calls, the relationship between them. We need to keep state of what exactly is happening at every point of time. So that's an example for a pretty sophisticated behavioral signature. And the other way, which is also quite interesting, is you can write signatures in Rego, which is Rego is, you might be familiar with OPA, the Open Policy Agent. This is a pretty popular CNCF project for enforcing policies, and we let you also write Tracy signatures using Rego, which is the language of OPA. So if anyone is writing or using OPA, the Open Policy Agent, which is very, very popular in the cloud native world, they can use those skills to write signatures for Tracy as well. This is an example for a Rego signature that looks for a ptrace with a ptrace_me argument, which indicates an anti-debugging technique. Never mind the signature here. Just we have these two options. Both of them are pretty unique because it's not just a simple predicate that you can say, okay, if the event name is that, then do something. You can really build up pretty complex behavioral patterns. All right, so this entire experience is currently packaged into a Docker container that people can just run, and it takes care of running Tracy eBPF and creating the stream of events, passing this into Tracy rules, loading all of the signatures. We have built-in signatures that we ship with Tracy, and this is actually backed by actual research that is being done by our security research team. So we will start building this library of behavioral signatures. And again, everything that I'm showing you is open source, so you can go and check it out yourself later. If I'm running this, let's do two things. First of all, I'm going to run this Docker run this container. Never mind these settings here. Basically, the image name is Tracy, and I'm telling it to trace. Trace will just start the Tracy eBPF component, which is just dumping a lot of information here. There's a lot of things going on this machine, so we can see the raw data here. This is a bit overwhelming, so I'm going to start it now without telling it anything more, which will start Tracy eBPF. It will load signatures into Tracy rules, and we'll connect the two. And in this case, I'm going to go over here, and I'm going to simulate an anti-debugging technique. It's a behavior that we sometimes associate with malicious behavior. And once I do that, we can go here and see that it was picked up by Tracy. We have a detection for this signature, which is anti-debugging, and also this is currently using a Falco Sidekick, which is a nice tool that allows us to pass that detection on to other systems that you might use. For example, Slack, Prometheus, email, or whatever. So I actually forgot to open Slack here, but it's currently configured to send messages to this Slack workspace that actually I think that you are not seeing at the moment. Let me see, how am I sharing that? All right, never mind. I think I'm not going to mess with Google meet today. Trust me, it's on my Slack window on my other monitor. Yeah, so that was a very quick demo. There's like a ton to show here. I just wanted to give you a general sense of what's going on, what it does, and I want to, besides the technical stuff, we are already scanning a lot of things. For example, we are scanning Docker Hub and looking for malicious behavior there, and we actually have a lot of success in that. If you go to the Aqua blog, for example, you can see a lot of breakdowns and analysis of what we found there. And we do the same for packages. So I think that this is where the presentation becomes more of a discussion on, like, if you find this interesting. First of all, I think that you have been doing conceptually similar things with the package fits project and the package malware project, I think it's called. And we would love to see if Tracy can fit in there. We can also help not only with the engineering part of it, but also with some, thinking about what to look for and how to look for it and so on. Yeah, and like, I want to hear what you think about it, first of all.
Yeah, this looks awesome. We're just trying to find all the different ways to look for malware we can, and experiment and play around with it a little bit. Anything that helps us, find more things and then filter out noise to get better lists of things we can look through manually to try to detect this stuff is useful.
Yeah, Dan, I don't know of any particular reason that we even have to pick the one true way. Use multiple tools, and there are obviously advantages to working on rules. This is almost kind of a side note, but I noticed you're looking at the the anti-debugging kinds of things. I'm actually a very big fan of that because, well, obviously it's perfectly possible for a proprietary program to want to hide what it's doing because they believe their algorithms are super secret special sauce. What's great about that is that since it's often a really good indicator of a problem, that they either make it easier for them to be traced, or they reveal there's a problem by using anti-debugging techniques. So, and I would think that any open source project that starts to trigger anti-debugging techniques is already way high on the worry list.
Yeah, I have something to add to that, actually. One of the cool things about the eBPF technology is that we're doing all the tracing straight from the kernel. So there is nothing in user space, which means that most anti-debugging techniques that are based on using the ptrace syscall won't be triggered. So we actually have the ability to trace everything that happens in the container in a manner that the malware can detect that is being detected, unless he has root, and then he has the ability to query if there is another eBPF program running. So yeah.
Yeah, if somebody has root, that's a completely different problem.
Yeah. But when you do the analysis from a container on a different namespace and you monitor everything from the kernel, you get a pretty good visibility without the other side having visibility. So I guess this is
I would hate to say that it can't be detected. Can't is a really hard word.
No. If
but
you're
harder.
a security professional, you never say can.
No, you never say sure. Can't, but harder. I would acknowledge.
For sure.
So what kind of similar technologies are you already? I mean, I see that you already have some kind of framework in place, and I want to ask what does it look like today, and how if you think that we can leverage tracing inside of this framework, where can it be and how?
I can give a little info there on what's set up, why we did it this way, what the real goal is. So we've decoupled things a bit. So there's one project which is just package feeds. I'm not sure if Jordan's here, but the idea there is just to get a uniform way to watch all the package registries. for like a uniform API to subscribe to, so you can see all new packages and new versions coming across as many languages as we can. They all have RSS feeds or databases you can query, or APIs or things like that, but you've got to figure out each one. So there's no easy way to just watch them all. Then from that, we've set up just a couple different experiments on things we can do with that data. One of them is the malware analysis pipeline that I set up so far with the Falco rules. The idea is to do as many different ones as we can there and make them pluggable. And what I really want to do is just set up a way where people with ideas or researchers and stuff can come with different analyses they can do, like typo squatting or things like that. And we can give a real production place to put those rules and pay for the infrastructure and keep them running long term. One of the things we see is, a lot of people like Jordan and universities and stuff doing reports every 6 months or so and looking for typo squatting or malware on their own credit cards and their own budget, and they find stuff and they publish it, and everybody talks about it and gets worried about it for a little while, and those packages get taken down, and then everyone forgets about it and nobody remembers again until somebody runs one of those one-off analyses again in 6 months. So my real vision for this is a way to kind of stop this that cycle of people forgetting about it and give people an easy way to get something like this productionized.
All right, so by the way, when I said package feed earlier, I probably should have said Malware Analysis. Is this the name of the project?
It started as one, but we kind of split it to two, so it's a little confusing. So we set up the package feeds to be independent and just kind of stop at the feed of new packages, and then we've decoupled it. So the other part is now just looking for the malware, but it all started in one repo, and it's pretty.
All right, and it sounds like we could. Yeah, sorry.
Yeah, I was to say it has split into two repos now, hasn't it? Or is that still not happened?
Yeah, two repos now. Naveen did a bunch of that work.
Okay.
And it sounds like we could use the package feed one on its own, because we also scan package repositories, so that could be really, really cool for us. And okay, so you mentioned that you're using Falco rules today. So is this using rules that you have written yourself to?
Yep.
What do you look for exactly?
Yeah, I don't really know anything about Falco or rules. I just kind of hacked something together. Right now, it's just logging, I think, every file name that gets opened when you do a pip install or an npm install of a specific version. So it's logging that, and then we can go through and look for suspicious stuff later. All of that data now just gets published into a whole bunch of JSON files that we can look through whenever we decide what to look for.
So that how do you do that later step? Is that manual, or
which part?
What do you look for? So you log every file that is being touched, and then how do you know which one is suspicious or?
Yeah, we don't yet. I've been looking through manually, and I've been able to find some stuff just by kind of scrolling through. We found a bunch of spam that was getting uploaded to PyPy, all these all capitals, click here to get free Discord credits, that kind of stuff. People doing SEO style attacks just manually, but nothing automated yet. We're trying to figure out the right formats and also make that data available so other people that have ideas can run queries later without having to set this stuff up.
On that note, do you have specific idea as to how Tracy can come and plug this in and solve this problem? Or if you already have that, it'd be nice if you can write that up and post in GitHub, so essentially everybody can read that and run with that.
So was that a question for me or for Dan?
Yeah, sorry, it was for you.
All right.
Not for Dan.
Yeah, I'm pretty sure that we can reach a similar point where we give the list of files that were touched. That would be quite easy to do. Actually, there's a lot of other capabilities of Tracy that I didn't show around forensics. So, for example, if you were talking about which files were accessed, so for example, we have some way for the operator to say, I want Tracy to capture everything that was executed during the trace, or I want Tracy to capture every file that was written, or every, we have some very specific things, like, for example, if we identify a memory unpacking behavior, we can grab that memory region from memory and dump it to disk. So we have a lot of capabilities around that. So in addition to generating a list of files, which should be quite easy to do with Tracy, we can also give the files, and then we can do further analysis on them, even just scanning them with anti-malware, but also do further analysis on them. Just to answer the original question, I think that it can, based on what I understand from the context that Dan said, it should be quite easy to fit Tracy in. Actually, I don't know how exactly, if this was the question, but probably can figure it out.
Yeah, I can send some links and pointers on Slack and give access to any of the stuff so you can see exactly how it all works, and we can come up with a plan from there.
Yeah, I want to add something regarding like the files. I know that Itai mentioned that before, but I'm just double clicking on it again. So I think one of the key things that we did, because again, we build it for security purposes from the ground up. So one of the things that we wanted to do is exactly to understand exactly which file, if they touch something in the operating system, they are writing into cron, they're putting a code in cron job to do a persistency or anything like that. So one of the problems with using syscall is basically that you can get a relative path, not only the absolute path. So, and this can create a lot of problems when you want to do, or if someone's trying to do an execv, but they're using an alias, for example, this is the kind of things that when you're using syscall can sometimes bypass your detection. So this is why we did further research into the Linux kernel. We actually placed hooks lower at the stack at the LSM hooks level. And there we are actually, when we are doing execv, when you're executing a binary, there is going to be an LSM hook check that is going to take the absolute path. So we are actually hooking and getting the absolute path of the file that is being executed. And this is something a lot more robust when you want to do security analysis, when you know something is happening. The same goes with when you're opening a file. If it's a relative file or something like that, you can still use a security file open, which is another LSM hook that we're using in order to detect the absolute path of the file on disk. And this is very helpful in the context of security.
Also, if a file descriptor is being opened, they do an exec and they give you file descriptor 3, you can't do anything with this information. If you just trace the execv system call, you will see 3.
Right.
Okay, great. Now what? But we can actually follow through and give you the actual file.
Mike, you sent me something a long time ago, like one that I still haven't quite looked through. You have something like this for SSH audit logging too, right? Where you can log certain commands that people run and you stick all of that somewhere that can be easily searched and queried, that we were thinking maybe could be similar.
Yeah, we're doing something similar. It sounds like Tracy actually has a more sophistication around filtering and probably is a closer match to your needs. What we're doing in our one of our SSH product features is just tracing all of the syscalls. We're using eBPF, so I'm actually learning a thing or two about the LSM hook stuff, which is interesting, and collecting that to just create sort of a trace of an entire SSH session. But it sounds like the Tracy toolkit is probably a better fit for what you're trying to do, Dan.
What I like about Tracy is you can write in Go, which is super easy compared to writing in C. My 2 cents.
Yeah, we get that a lot.
Yeah.
And actually, there's another layer of the Rego, which is actually a further simplification because it's a DSL.
I don't like it. Sorry. I like programming language. Yeah, right.
All right, I forget that I said it.
Yeah. Wait, what's the other language besides Go? The DSL?
It's
called Rego.
Yeah,
Rego is the language behind OPA, the Open Policy Agent.
Right. Okay.
So
got it.
Actually, the reason it's
by the way, for those of us programming in
people,
C since the 80s, then I think 1980 or so, I wouldn't say Go is necessarily easier, but that's okay. Anyway, sorry, I just thought I'd represent for some of us who've been around a little bit longer.
So coming back to the previous question, I would love to take a look, for example, on what you suggested, Dan. I think the SSH a logging, like if a general question, like if you see a place where you would like our help to see if like we can help plug Tracy in and help you understand what to do there, like, we can help, and we would love, because our goal is to make Tracy better by more people using it, getting more feedback. So any opportunity for others to use Tracy, we'd love, and we'd love to also help in like implementing it.
Hey, since I already interrupted your thought, can I ask a question here? So, by the way, this is great stuff. I love it. I think any kind of capability you get to get deeper introspection and automation around tracing, I think is really, really helpful. I think relative to securing critical projects, which is our charter, right, is the idea here that if you have a project that's perhaps considered pretty critical, but it doesn't have a very good maintainership around it, which I think is probably one of our big challenges, right? Is the whole idea that the community, somebody puts together some automation around Tracy, some rules, or around Falca or something else of this sort that we could then, as these things get updated, we can kind of do a little bit of some rules tracing to see if the behavior is somehow changed. Is that kind of the approach we want to take with this? Is that, I'm sorry if this is a stupid question, but this is sort of just trying to relate this back to the charter.
Yeah, if I can jump. Oh, sorry, go ahead.
Go ahead, David.
I was going to say, I'm not so sure that right now it's noting changes. It's just looking for suspicious behavior and focusing more on the malware side. We've got two different issues. One is the unintentional problems, and one is the, it's the package has gone bad. It's, it for whatever reason, it now has malicious code in there. Could be a malicious developer, could be somebody's account's been taken over, but for some reason, it's gone bad. You raised an interesting point that we could do a difference between old and new and notice real big changes. I don't think, Dan, that was something that you had mentioned, although I don't see any reason that we couldn't do that. I don't think it does it now.
I mean, I see a real use of these things as sort of signal generators. If you think, between signal and noise, right? And if you're running an infrastructure of any sort, right, having a good set of signal sources is supremely important, which that immediately I saw here. I'm just, again, trying to, get us a little focused relative to what we're trying to accomplish, which is to identify those, pimples, if you will, in our, our beautiful open source space, and figure out which ones are maybe need to get a little bit more attention. Maybe that was a bad analogy.
Yeah, and I think I'm trying to remember how we started working on this here, and now I think it finally came back to me. The real history and how it's the charter and everything is some folks from the Python Software Foundation who run the PyPy infrastructure came and presented way back on some of the stuff that they were trying to do here and ways we could help out.
Oh, right.
So there's multiple levels of projects. There's projects running the hosting
Right.
for other projects, and then there's us trying to help these other projects. So I think, we're trying to help the package registries and all those communities figure out ways to productionize this type of analysis that they have to do, so they don't have to sift through all this, the signal to noise ratio.
We've been thinking about the same thing from the, so I work for Gradle. We have the Gradle plugin portal, which is, Gradle's used to build like 99% of all Android apps, and, we have no idea what's in the plugin portal. I mean, I think that's true with like a lot of artifact servers, right? Like I'm guessing there's nobody auditing Maven Central either, right? For Java packages. And
Right.
I think one of the comments that's really interesting is that like you see articles getting published about vulnerabilities and things like this, malicious in NPM and in pip. I think that one of the things that I've kind of correlated is if they're scripting languages, you've heard about it, but if they're compiled languages, it's actually way less common, just in general, to hear about it, at least in the major repositories, right, like Maven Central and stuff like that. So, yeah, and that's to say that it's probably happening. It's just not, as easy to find that stuff in those compiled languages where that's what's been packaged.
One exception there, I was looking at when we were setting up the package feeds, is crates.io for Rust. It's a compiled language, but they're very worried about this because the installation process is from source rather than binaries, and they have all these custom build scripts that get run, and it's a pretty big and scary thing. So they're looking at ways to sandbox the build process and the build scripts that people get to execute and all sorts of stuff there. But yeah, it can happen in a lot of places.
Right. Yeah, Dan, I realize, you want to first get something working, but at some point we probably ought to talk about how can we, set up something on some cloud services or something so that, I would love to hear, oh yes, every time something goes into PyPy or Ruby Gems or NPM or Cargo's repo, that, poof, it's run through this. And ideally, eventually, there's feedback loops to the various repos.
Yeah, that's exactly what I want to do, and I think we probably just need to do a better job of writing it all down because that is happening right now. And, the data's just sitting there, and nobody would look for it.
And this is part of the reason why I said I used the term specifically diffs, is because sometimes when you got, PyPI has, I don't know how many packages in it. It's a large number, right? And all the package feeds, whether NPM or whatever, they have a lot of stuff in there that it's very difficult to know what's in there and what might have been, subverted. So something that would at least show, oh, there's a diff, and it's like, okay, well, who's going to look at the diff, right? Because you may not know any better than that, but it's like, oh, look, it opens a bunch more file descriptors that are like, ooh, wonder what's going on, right? So something of that sort that at least gives you, now, of course, those things can be hidden, avoided too, if people know what you're looking for, but at least it gives something, right? Some sort of signal.
I just linked a doc, and I haven't taken a look at it in a while in the notes, just sort of some ideas and things that I had for the whole project. So feel free to, take a look at that and make comments, suggestions. I think it's a little outdated now because they have split up the projects like Dan said, but yeah, feel free to chime in there. Link in the chat.
Yeah, there's actually a repo called a website called module counts, which counts packages. It seems to be down right now, unfortunately. But it makes some cool graphs. It is a little misleading. If you look at it, you discover that there's more JavaScript packages than any other. But what that really tells you is the radically different ecosystem approaches. And JavaScript is full. Nearly half of all JavaScript packages have either 0 or 1 function. So you'll have things like isOdd is its own package, which basically doesn't happen in any other ecosystem. So, but it's certainly true that there's a whole lot of packages in these major languages.
One plug, Dan mentioned typo squatting, so that's something I want to see if we can get integrated within this malware detection thing too. If anyone knows of open source projects around typo squatting or research that's happening, please reach out or let me know. I'm talking to a couple of universities to see they've done some research in this space, but I think it would be cool if we could.
Yeah, I spoke to, so I was at the GitHub Packaging Summit, which was a closed summit that GitHub held for a bunch of packaging maintainers. And there is some, ping me on Slack and I'll put you in touch with somebody at GitHub that it was working, GitHub and Microsoft that was working on something like this.
Okay, yeah, I know some of the folks at Microsoft, I think they dropped off that call, but yeah, I've been talking to them as well.
I think it's Martin Woodward was at least, or William Bars can at least put me in touch with the right people.
Okay.
Yeah.
Awesome, thank you.
Yeah, I don't have any new insights, Kim, for the, I know there's typo squatting research, and I think you're already talking to folks that I know of. But I did find something related that might be of use. I recently discovered that Postgres can do Liebenstein distances indexed.
Oh, nice.
Which is quite a trick. So I'll tell you the trick.
Nice.
Basically, what they do is they index soundex, and that gets rid of most of that makes it much easier, and then they use that to and then use compute Liebenstein distances on the remainder, and that makes it suddenly super fast. For those who don't know, Liebenstein distance is a measure for how far apart two words are or two phrases, and although it's not a perfect proxy for typo squatting, it's still pretty darn good. The hyphen versus dash, the A versus the E, kinds of stuff. So if you want, I can try to hunt that up. But that actually may be one of those things that turns it from a day job into seconds job.
Sure. Yeah, I think from what I've been reading about it too, there's ways to, there's some more like deeper analysis that we could look into doing, like looking at the actual package contents, and then comparing it to what we think is like the known good package, and then getting some signal that way. But yeah, I mean, I'm open to all ideas and interesting research in this area.
We also tried to.
I mean, one of the things so typo squatting is I mean, it's just real risk that we've been dealing with. But like, I mean, that recent disclosure about the guy that made $130,000 off of like just stepping on the same names as companies were using, organizations were using, like, those kinds of things. It's much harder to do in the Java ecosystem. But I work for Gradle. I have some ideas of like how those kinds of things could play out in the Java ecosystem, just like anything else. It's just harder to pull off. I mean, it might require a little more social engineering, but like those things do, exist, and packaging maintainers want to make these like really light packages, and they want to have names that are really simple and easy. But like, the Java ecosystem tried to solve this really early on with like DNS, using DNS as like an ownership component around like, you own DNS. You can own that namespace for a packaging ecosystem.
Yeah.
And I don't know, it sounds like, the thing that NPM published about like their response to that was like, great, like register your namespace with us. And it's like, this wouldn't be as much of a problem if like more ecosystems adopted DNS as like a standard for like claiming a namespace.
One other thing I want to mention there, Kim and I were trying to get creative and think of other ways to do this. And one of the ideas we came up with and we got stuck on, other people might have ideas, was to do like a kaggle or ML competition here, which people do. Like, we have all this data, can somebody train a model to detect or better filter this out? And we started to run into all these weird ethical things where to do one of these competitions, you have to have a bunch of known bad data to test against. And so it would require us to either make a bunch of fake stuff, which is going to get weird and artificial, or to know about a bunch of actual bad packages and not tell anyone about them, and to keep this private for a while to run the actual competition. So we couldn't, it still seems like a pretty good idea to make this data available and let people try to find all the stuff they can, but we couldn't come up with a way to actually do it as like a funded competition because of the weird ethical stuff around fake data and security.
Could you create benign bad packages?
Yeah, I was thinking about that, but then they get like it's artificial, and I don't know how accurate that would be.
Yeah.
And people could kind of just go through and look for our little Easter eggs rather than the real ones.
I've been thinking about trying to build a CTF around this, right? Like some sort of like or bug, like an ad hoc bug bounty program around like, hey, like here's a build that's running. We run this on a cron job as a part of a GitHub action. There's a secret in an environment variable. Pop the environment variable.
Yeah, I mean, doing that sort of bounty thing is sort of exactly what we're trying to do within the OpenSSF in this working group, but it's just been a little bit tricky to get consensus on how we're going to handle funding requests and the process and everything. So, but in the meantime, I mean, like me on the Google side, we're really interested in this. So if there's things we can do like that, that there's interest, then I'm happy to take that on. Yeah, so yeah, I'll ping you on Slack and get some names too.
To be fair, I don't think we have to start fancy. So many of the typo squats that I've seen, the ridiculousness of them is that they're so trivial. So I think we could frankly go a long way without trying to create a machine learning model and so on, and just going for much simpler approaches.
Yeah,
somebody raised their hand. I want to just make sure that if it wasn't an accident, make sure they have a chance to talk. Art.
Yeah, sorry. I apologize, everyone. I joined late and have not been tracking this particular OpenSSF working group, so I'm still going to commit the mild sin of speaking during my first meeting. Could someone just quickly, is one of the goals of this working group to identify basically critical packages, and this is, you know, one way to do that is this discussion of how common are things, how linked are they. I guess I'll just quickly ask. Yeah, thank you, David. I guess I'm asking for the high level. The goal here seems to be, from what bits I've read and heard, that how do we actually identify or measure the most critical things out there, and then they might warrant additional security investment, right? Is that the idea? Okay.
That was the critical. There's a criticality score project. As far as, am I correct about that?
That's
Yes,
one of them.
One project, criticality score, that's in the OpenSSF now. And Jenny, I see her on the call from Harvard's LISH group, that they've been doing a lot of research for the Census 2 study. So absolutely yes is the answer to your question. Still needs work, and see how we can better the approach for identifying them.
Okay.
Is the criticality score project applies to packages or to like projects?
I think it's just GitHub, like using a GitHub repo right now, but someone else might know better than me if we've expanded it. Yeah. Cool.
We have 2 ongoing projects, and I've tried to list them in the notes.
Got it. Reading up now. Thank you. Yeah.
I started a doc too. I don't know if I can find it, but like we've started a conversation of just about the security critical projects, meaning, you know, projects that if they were if they were attacked, they would have a much more detrimental effect on the ecosystem than, you know, others, because they have access to different things. So I'll see if I can dig that up and add it to the notes too. It's just a brainstorming doc, but maybe we can pick up that work at some point too in discussion. Cool. Well, thank you so much for the presentation on Tracy. That was awesome, and I hope we can see some more collaboration and see if we can integrate these things. Does anyone have any last minute questions or about at the time?
No, I just wanted to quickly say, yeah, follow up on Slack, and I can show you where all the code and clusters and all of that stuff are, so you can get an overview of how everything's currently set up, and we can figure out how to go from there. Thanks, Itay.
Thanks. Just a quick question about the current projects. Can you just maybe quickly share the context of, like, what's the plan with the package feeds and the malware analysis? Is there like is there a plan, or what's your expectations for where these are going? You mentioned that it was triggered by a request from the package repository maintainers. Is there like an ongoing collaboration with them? Are they expected to use that at some point? Or is the OpenSSF expected to publish this at some point?
Yeah, so I linked the doc that I had started. And one of the things that I was trying to do and add to that doc is figure out how we could integrate with package managers. Like, some of them, it just seems like they have an email address. Like, if we detect something suspicious, should we just email that email address and have them take a look? Dan, were you going to add something?
I was just going to say, yeah, Kim's doc has probably the best state for the overall, you know, vision, which is still very malleable. But yeah, we do have ongoing relationships with the package maintainer repositories and stuff, and we want to find stuff, help them, publish it, all of the above, like you said.
Yeah, so I think clearly contacting the package managers. I think ideally, I would love to see more integration with the package management tools. You know, so that when when you try to do pip install, it's suddenly, wait a minute here, that's highly suspicious. Are you sure you want to do that? And another project, which is actually a different working group, is the security metrics working group. They're trying to create a dashboard and yank in lots of data from different sources. And so data from the malware analysis would be an obvious thing to suck into that as part of their overall display about, you know, I want to know about a project, and it tries to suck in different data sources to show in one place, and that would be another good thing to integrate with. And I think that wouldn't be hard. Just, I mean, if you provide an API to get the data, they can take it from there.
Yeah, I'm relatively new to this project as well. I think something that would be useful about package feeds is that if it gets a critical mass around the number of repos it has, it might also influence back to the repos over having decent APIs to get that data. Like, for example, PyPI, I understand, is just an RSS feed and you can miss things and they don't want to be polled heavily. So maybe there's like scope there to have a more standard way of consuming that data.
Yeah, absolutely. We can work with them on that stuff.
Okay.
All right, I just found the link to that doc and stuck it in the meeting notes if you have access. Critical projects. Cool. All right. Well, thank you, everyone. Good seeing everybody, and hope you have a good rest of your day.
Awesome.
Thank you.
Thanks so much.
Thank you.
Bye-bye.
Have a great day.
Bye-bye. You too.
Okay.
Bye-bye.
Bye.